We want to take this expression and combine it to be a single term. So there's 3 terms here. There's 1, 2, 3 terms. Do they all have the same base? They all have a base 3. So they do all have the same base, which allows us to now shrink this expression into a single term. What I'm going to do is I'm going to rewrite log base 3, and then I'm going to use my product rule. So this will be a product rule. So that's going to become x plus 2 times x. Now I'm going to rewrite that log base 3 of x times x plus 2. So there's my product rule, minus log base 3 of 2. So now I have a positive logarithm and a negative logarithm. Now we're going to use the quotient rule. So this is our quotient rule now. So our quotient rule says log base 3, and now I'm going to make a fraction. What goes in the numerator? The positive logarithm's argument goes in the numerator. That's x times x plus 2. And the negative logarithm's argument goes in the denominator. And now we have successfully rewritten the original expression as a single logarithm. Now, I will do these problems much faster. I'm not going to be showing all of this work on the future problems. So I want to show you very quickly how I do this. So if you listen carefully, you're going to be able to simplify these or condense these logarithms as quickly as I do. I recognize that I have the same base, so that's a log base 3. Then I look for the positive logarithms. Positive logarithms are going to go in the numerator, and they're going to become factors of one another. So they're going to become a product. So the arguments will become factors of a product. So the factors are x and x plus 2. I write the monomial first. Then I look at the negative logarithm. Let me write this in red so you know where that came from. So the positive logarithms become a product in the numerator, and the negative logarithms, so this log base 3 of 2 has a negative out front, its argument is going to go in the denominator. Then of course you know that I like to write the argument in parentheses. So that's how quickly I go from 3 terms to 1 term, and there's very little to no work that I show. Okay, let's try another. We're going to combine this expression to be 1 term with a coefficient of 1. So when they say a coefficient of 1, I'm highlighting that in blue. Here's my coefficient. Here's my coefficient. I need to take care of those coefficients. So the first thing I'm going to do is rewrite this with coefficients of 1. So that 2 is going to become an exponent to the argument, minus this 3 is going to become an exponent to the entire argument, which is n. And then of course you know that I like to write my arguments in parentheses there. Now I have 2 logarithms with the same base, log base a, and one is positive and one is negative. The positive logarithm's argument is going to go in the numerator. So I'm going to have a fraction. It's going to go in the numerator, m squared. And the negative logarithm's argument is going to go in the denominator. And we have successfully rewritten our expression to be 1 term with a coefficient of 1. We're going to get a little bit more complicated here, but I feel fairly certain that you're going to be able to follow me. I have 3 logarithms, so I'm going to have 3 factors. Now I'm going to show you this using some color. Log base b. The next thing I do is I say, am I going to have a fraction? Well, I've got a positive logarithm, and I have a negative logarithm. So indeed, I am going to have a fraction. So I make my fraction bar. I'm going to put parentheses or brackets around that fraction. So my positive logarithms are going to go in the numerator. 1/2 is going to become an exponent, and an exponent of 1/2 is the square root. So that's going to become the square root of y. Times, now I've got 3/2 is going to become an exponent of both 2 and the factor x. So I'm going to have 2x raised to the 3/2 power. Now, I went a little bit slow there because I'm going to show another step because I didn't want to do too much in one step. Then again, this negative tells me that I'm going to have the argument in the denominator. So x, y squared. There was no number here. If I think about putting a 1 there, it's just raised to the first power. The negative tells me the denominator, and all of the argument goes in the denominator that's attached to that negative logarithm. So now I'm going to just take this 3/2 power and I'm going to make it a little bit cleaner. Log base b, and I've got a square root. So I've got the square root of y times the square root of all of 2x raised to the 3rd power, xy squared. Log base b, 2 to the 3rd power is 8, x to the 3rd power is x cubed. I have 2 radicals here, and when you multiply radicals, the radical becomes 1, and you just multiply the radicands. So I'll have 8x cubed y, 8x cubed y over xy squared. And that's a pretty good answer. That's a pretty good answer right there. Now there's some different things that we can do with that. So we could maybe even simplify it a little bit more. We could simplify it a little bit more, but that wouldn't be too bad. We could take out a 2 and an x, right? So I'd take out a 2 and an x, and that would leave me, let me write this, log base b. So I can break down that radical, and that would leave me a 2xy, right? Because 2, 2, 2, x, 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 and a y. I'd have a pair of 2's, a pair of x's, so that's where the 2x comes from. And then what's left over is 2xy. And then xy squared, right? And then these x's cancel out, so you could see an answer on an answer key that had 2 times the square root of 2xy over y squared. And that's if we use all of our algebraic tools that we've learned to this point in all of our algebra classes. That's what could result. Now we're going to have a try. So we want to combine this. So here we have a try. It says example. But let's see what you can do. Now, when you write this log of 2x, just make sure that 2x is in parentheses there. I don't like the way it printed with that font. That's what it is. We're going to make this a try. And we're going to come back, give you the answer to this one, and then we're going to go on to another concept.